Okay, so we will start Physics Form 4, Chapter 2, Force and Motion. So the first one, we will learn about physical quantity, which is the very basic things in physics. And I divide it into two sections, which is scalar quantity and vector quantity. Scalar quantity is a quantity that being measured and have its own magnitude without direction. So vector, it have magnitude and also direction. So for the scalar, let's see for the physical quantity under the scalar, which is distance. Distance is like an object moves from this place to another place. So the distance is being measured in meter, the SI unit. And then next one is speed. Speed is rate of change of distance. That means the distance change divided by time. That means how fast an object moves within 1 second. Okay, so we will see the formula later. And for vector displacement, displacement is just like distance, but the difference is it is the distance from its final position to the initial position, and it also have magnitude because it is a vector quantity, right? So and next one is a velocity. Velocity is also based on displacement, which is the rate of change of displacement. Means displacement over time. We got them how fast it is moving at 1 second. The next one is acceleration. Acceleration is rate of velocity change, which is velocity over time. Final velocity minus initial velocity divided by time, and the unit is meter per second square. So we will see the formula later. So now we will see the equation of the speed and velocity acceleration. So the speed is distance over time, like I said before. Distance over time, velocity, displacement over time, acceleration is change in velocity or final velocity minus initial velocity divided by time. Okay, this is the 4 formula that you have to memorize because it will be easier to use this under certain condition. Motion with uniform acceleration. Okay, a car is accelerated at 4. First of all, when you got a question, please list down the information given. So acceleration at 4 means a equal to 4 and initial velocity, which is u equal to 5, 10 seconds is t. So just list. The question is distance. So just list first acceleration, initial velocity. So what is not included in here? The final velocity is not given. So based on the 4 formula I have mentioned before, you can choose which is suitable. And for this case, this formula is chosen for the example. So just substitute u, which is 5, t, which is 10, and a, which is 4. And we can get the distance to 150 meters. Okay, next one, we move on to the ticker timer. Ticker timer is an object to measure velocity and acceleration. So between this, the time taken, it is said that time taken for the 50 ticks is 1 second. That means 1 second. In the time 1 second, there are already 50 dots, 50 ticks. So if we divide by 50, we got that the interval between two dots, between this dot, two dots is 0.02 seconds. So we can use this to determine the velocity and acceleration. So this is some of the condition that I took. For this one is, you see the dot is uniform at the same distance. So from this we can say that the velocity is in a uniform state. Next one is, at first the dot is near and it got bigger distance. So from this we can say that it has acceleration. So we can conclude it is as a uniform acceleration. The next one is, from at first it seems like a bigger distance and now shorter, so it can be called as uniform deceleration. Caution: T is the time taken for the first dot to the last. So now we move on to the example. So okay, see the ticker tape here. Okay, when it say direction from here, that means it start from here. So first of all, start from here. That means this one is the initial velocity, and this one is the final velocity. Yeah? So let's read the question. The ticker tape is being produced. If the ticker tape produces 50 dots per second, find the acceleration. So we have to find the acceleration here. So when the formula of acceleration is here, right? V minus u divided by t, which is final velocity minus by initial velocity divided by t. So we calculate the initial velocity first, which is this part. Distance, displacement over time, 3 minus by 0.02 second, we got 150, and the final 0.5 divided by 0.02, and we got 25. So we put in the formula, or no, we have to find t first. T is 0.5 plus 4 and plus 0.5. 5 times by 0.2, we got 0.1, and substitute in the formula, we got negative 1250. Next is graph of motion. Okay, this I compile of all of the graph, which is graph of displacement versus time. Okay, from the graph, if we find the gradient of the graph, every gradient, we will get the velocity. Why? Because the formula to find the gradient is y divided by x. So displacement divided by time, we got velocity. So for this graph, we can say that the gradient is 0. That means the velocity is 0. Next one is, when we find the gradient, we got the gradient as a constant. So we can say that the velocity is uniform here. Next one is the same as before. It's just in different direction, because we got the negative gradient. That means the velocity is uniform, but is in opposite direction. Next one, this shape is, it determines the gradient is increasing, so that means the velocity is increasing here. Same goes to this one, the velocity is decreasing here. Now is the graph of velocity versus time. So from velocity velocity divided by time, we got acceleration. So all the gradient in this graph, we got as acceleration. So for this, we got the constant velocity. This one is velocity. So constant, or uniform velocity without any acceleration, no acceleration here. So for this one, we have acceleration here, uniform acceleration, because we got a uniform gradient. Next one is also deceleration here. We have a deceleration here, and this one is the increasing acceleration, and for this one, decreasing acceleration. As simple as that. So we move on to the inertia. Inertia is when we say that every object continues in its states of rest or of uniform motion unless it is acted upon by an external force. So as an example here, this is coin. When we when the cardboard is pulled away quickly, we must do it quickly. The coins drop straight into the glass. So that means the inertia of the coin maintain its state. Means it resists. It stay at its original state. If there are no gravity here, the coin will stay there. So for the books, it's just the same concept here. And relationship between inertia and mass, which is the larger the mass, the larger the inertia. Next is momentum. Momentum is product of mass and velocity. That means mass times by velocity. So it is also a part of a vector quantity. The SI unit is kg/ms -1. Okay. So this one is the principle of conservation of momentum. So it says that the total momentum is constant before the total momentum before the collision is equal to the total momentum after the collision if there are no external force act on the system. So we can write the formula as this: m1 u1 is initial velocity and v1 is final velocity. Okay, there are two collision here, which is elastic collision and inelastic collision. Elastic collision, in easy word, we say that they crash and they separate. And for inelastic, they crash and they go together. They both, for elastic collision, both objects move independently after the collision. So it says that momentum is conserved. Kinetic energy is conserved and total energy is conserved for the elastic collision. For inelastic, the two objects combine and move together with a moment. That means when two objects with different velocity, they crash and then they move together with only one velocity. Let's see example here. Both objects are in the same direction before collision. So for the case, same direction. So the car A, there must be car A and then car B. So two objects, two mass here. We will get two mass and two velocity. So mass of 600 kg moving at 40, m1, v1, u1 40, and then m2 and u2. In the same direction. If the car moves forward at 30 ms, mean is V2 here because it is V. What is the V1? V of A. So first of all, just list the information first. M1, M2, U1. Okay, so just use the formula here: M1 U1 plus M2 U2, and so on. Just substitute here. And we got V1 equal to 26.67 ms -1. The next example is on inelastic collision, because a lorry of mass 8,000 kg m1 and m2 u1 u2. So v1 and v2, we can see that they are moving together, right? So we can combine it into v only. Use the formula and then we can find the V. V equal to 28.42 ms -1. There are also explosion here. It say that before explosion, both objects stick together. Explosion is also part of momentum. After the collision, both objects move in opposite direction. Okay, so before is 0, after is still m1 v1. So we look at the formula here: total before equal to after. So just put at the before one, put it as 0, and we will got the negative m1 v1 equal to negative m2 v2. That means this negative, what does it mean? In opposite direction. That is what meant by move in opposite direction. So we can look at the example here. A man fires a rifle which has mass as usual. Just list the information first. M1 2.5 and 2 0.01, which is 10 gram. Convert it to kg because the SI unit is in kg. U is 0. U of course is 0 because before collision. Okay, so V1, we have to find the V1, and we are given with V2 250, and just write the equation, substitute before as 0, and we can get the V1. which is the fifth one, meter per second. Next one, we move to the force. Force is a push or pull exerted on an object. So it is a vector quantity which has magnitude and direction. We know that the unit of force is Newton. So we look at the Newton's first law. When there is no net force acting on an object, the object is either stationary or move with constant speed in a straight line. So for Newton's second law, just remember it as F equal to ma. M is mass, A is acceleration. That is the very basic thing. Next one is the resultant force. When the forces acting on an object are not balanced, there must be a net force. So resultant force is a net force. This is the example. A box of mass 150 kg is placed on the horizontal floor with a smooth surface. So find the acceleration. So just F equal to ma. Remember F equal to ma. It is already given F and also m. We have to find A. So A equal to F over m. So we got it as 2 meter per second square. So we move on to the impulse. Impulse, it is a vector quantity which has direction. It's defined as the product of F acting on an object at the time. So F multiplied by time. Impulse exerted on an object is equal to the momentum change of the object. So impulse equal to mv minus mu. Next one is impulsive force, and it is defined as the rate of change of momentum in a reaction. So change of momentum divided by time. So mv minus mu divided by time. Okay, this is the example. Remember, for momentum, mv momentum, impulsive force, mv minus mu, change in momentum. List down the formula and also the information first. M equal to 1000 kg, velocity is 25, and t is 0.05. Since m is the same, so we can just substitute it like that. And 1000 multiplied by final velocity minus 25 divided by 0.05 equal to negative 500 Newton. So here I prepare some application of impulsive force. Impulsive force is very common in our life, just maybe we did not realize it. Okay, for the first example is a long jump. Why we put the sand at the long jump? Because to increase the reaction. Same goes to the high jump. They will land on a thick soft mattress after the jump. This will increase the reaction time and reduce the impulsive force. Same goes to airbag here. The inflated airbag during an accident acts as a cushion to lessen the impact. So, in conclusion, the increase, the longer the time of reaction, the lower the impulsive force. Now we look at the gravitational force, which is an object falls because they are pulled towards the earth by the force of gravity. So that means when we are standing and we throw up a ball or an object, it will fall down due to the force, gravitational force. While for free fall, an object is falling freely when it is falling under the force of gravity only. So a piece of paper does not fall freely because it falls affected by air resistance. But everything in vacuum, which is no presence of air, so there is no air resistance to oppose the motion of the object, so they will fall with the same acceleration. So let's see case 1 from free fall, falling from high place. So the object is here and then he fall. When it fall with the acceleration of gravity, which is 10 ms negative 2. So, when an object is released from high place, its initial velocity u is 0, and the gravitational force is equal to acceleration, which is be taken as 10. Okay, that's all for my part, which is until the gravitational force or gravity.